Hi, today we'll be looking at Deepseek. So if you haven't heard the news, it's a Chinese company that released a bunch of open source AI models or large language models, and their performance is pretty good and comparable to some of the popular GPT models from OpenAI and also models from Google. So today we'll be looking at how you can run DeepSeek locally using Ollama and build an app with LangChain to chat with your PDFs. So let's get started. So as I said, DeepSeek is a Chinese artificial intelligence company that has developed some open source large language models. I won't go into a lot of the news, you can read it on your own. But basically today we'll be using Ollama, which lets you run open source models locally by using your own compute. So if you look at models, you can see the Deepseek-r1 is available, and today I'll be using the 1.5 billion, and you can choose whatever model is appropriate for your hardware, since you can see how the sizes of the models can increase depending on the parameters. So for me, 1.5 works, but in certain cases, you might have the ability, depending on the machine you have, to run the 7B, 8B, or even 14B. First things first, you'll need Ollama installed on your machine, which I already have, and I have a dedicated video on how to get Ollama running on Windows. So if I do Ollama ls, and as you can see, I have Gemma 2 and Phi 3 latest. So let's pull DeepSeek. So let's pull the DeepSeek. So in order to pull 1.5b, you can just copy this command, come into my terminal, and as you can see, it is pulling that model from Ollama's registry. If you look at the command, it was not Ollama pull, but Ollama run. Hence now I can send this a message. So let's say, tell me a bit about yourself. So as you can see, it says, I'm Deepseek-r1, an AI assistant created exclusively by the Chinese company Deepseek. I'll do my best to help you. So this is good. As you can see, I've also created the directory already where we'll be working today. So let me open that up in VS Code. Today, as I said, Ollama is already configured. The next thing we'll be using is LangChain. Now, I won't dive too deep into what LangChain is, but basically it's an open source framework that allows you to build LLM-powered application. I have a complete course on Free Code Camp that you can take for free if you're interested in learning about LangChain. As you can see, it's 1 hour long. I'll make sure it's linked down in the description. There are a bunch of imports that I'm doing on top, so which means I already have the requirements.txt. I've created the virtual environment, and yes, I'll be providing a GitHub repository with all the code so you can replicate this on your own environment. So if I go into requirements.txt, we have streamlit, we have LangChain core, LangChain community, and LangChain Ollama. Another one we need is the Pi PDF loader, also the Phi's CPU. So Phi's is an open source vector store from Meta, and you can basically run this locally. So if we go to Phi's, depending on how you pronounce this, you can see this is a library for efficient similarity search and clustering of dense vectors. So we'll use Phase as our vector store today. Now, if I go back, I've added those to the requirements.txt. Let's come back to main.py. As you can see, we'll be using Phase. You can also use in-memory vector store. Again, you're open to use any vector stores either locally or in cloud. So cloud ones are like VV8, Pinecone. Also, a good one is Azure AI Search. But yeah, feel free to choose whatever vector store fits your needs. The first thing would be, since we're building a PDF chat application, we'll need the PDF. So let's start with that. I'll create a PDFs directory. If we look at PDFs, I've created a folder. That is where our PDF will be uploaded. The next thing would be to use the Ollama LLM. So Ollama LLM is available from the LangChain community. Basically, you can tell which locally running model you want to use. So I'm initiating model, which will use Ollama LLM, and the model is Deepseek-r1. Same thing for embeddings. So I won't be using OpenAI embeddings because you'll need an API key. Instead, we'll be relying on DeepSeek here as well for creating the embeddings. Now, I'll be telling you where embeddings will be used, but if you're not familiar, I highly recommend, again, watching that LangChain course, because I talk about, how embeddings are created and what their purpose is, along with RAG as well, because basically we are implementing RAG today, which stands for Retrieval-Augmented Generation. But I won't go too deep. This will be a quick tutorial on how you can use DeepSeek. So the next thing will be a template. So if you have worked with LangChain, there is a prompt template that you can use to guide your LLM. So in my case, I have told it that you are an assistant that answers questions. Using the following retrieved information, answer the user questions. And if you don't know the answers, say that you don't know. I want it to be concise and to the point. So we'll also provide it the question that the user asks. Of course, this is going to be the question that you want to ask your PDF, and we'll also provide the relevant context. This is where RAG comes in. So that is going to be our template. Now, first I'll create a function to upload the PDF. So this will upload the file from our web interface. So you'll have the option to upload, whatever PDF you have to our web application. And then this will store that in the PDFs directory. The next one is a bit bigger function. So this is where we are using the embeddings model. We are also using the recursive character text splitter to chunk PDF into smaller chunks and then store it in the vector store. Remember, all of this comes from LangChain. So LangChain has the recursive character text splitter that I'm using. So I'll go step by step within this function. First, what we are doing is after the user has uploaded the PDF, I am using the PyPDF loader to load the content of that PDF. I'm storing that in the documents variable. Then I am creating a text splitter with the listed settings. So chunk size 2000 basically means it'll create one chunk or one smaller chunk out of that PDF that contains 2000 characters, and then I'll keep creating those. But then chunk overlap, what it does is it'll take those the last 300 characters and have them in the first. So the first chunk that got created and the second chunk that got created will have 300 characters overlapping, and like this you build like a chain, but the overlap basically allows you to not lose context or relevancy. Let's say, for example, if this chunk gets returned on our retrieval, maybe there was a line talking about some important topic which got into the next chunk. So when we do a search, it'll return both of those if the last line had some relevant context. And also I have set the start index to true. We take that text splitter with the listed settings and save the chunked documents into a variable called chunk docs. We add these to our phase vector store. So we use the chunk docs, including our embeddings model. So the embeddings of these chunks will be stored in our vector store, which is phase today. Basically, I'm saving that in a DB variable, and that DB is returned from this function. Now, the next function will be used to retrieve the relevant docs. So let's say the PDF is about something related to NVIDIA, and I want to know, how much NVIDIA stock was, 3 years ago. So the key phrases are NVIDIA stock 3 years ago, right? To get that relevant data from the vector store that we created from the PDF, we can do what is called a similarity search. So what a similarity search will do is it basically will take my query and return the documents. Here I have some other settings, like k is set to 4. This means the number of docs that will be returned because we have created them into chunks, right? So this means 4 chunks will be returned. Basically, I also have a print statement so that we can see what were the chunks that were returned, along with also the return statement, which is basically doing the similarity search using our vector store. So this will get us the relevant information, and this is basically what RAG is. The last function is where we create the chain. So this is a concept within LangChain. What I basically have done is created a question_PDF function. It takes 2 arguments, question and documents. Context is what we need the retrieved docs to be. Whatever is returned in retrieved docs, what I'm gonna do is take the page content from those chunks and join them into one doc. So I'm using this join statement here. So what this will do is, because k is set to 4, I'll have 4 different documents. I want them to be together as context. So that is why I'm storing it as context. The next is prompt. So as I was telling you about the prompt template, a concept within LangChain, we use it to guide our LLM. I'm basically passing that here. And in order to create a chain, as you can see here, what I've done is prompt pipe model. So model again is DeepSeek. Prompt is the template that I showed you before up top. right here. And then we do a chain.invoke. So this will run an invocation with question. Remember, our prompt template has two variables. So question is whatever user asks. Context is the relevant information or relevant docs that we pass. So I'm mapping that question to the question as the argument from this function, and context to be the context here, because as you can see, this documents argument is going to be passed into the context because we're doing the join, right? So I hope this makes sense. Now the next thing we'll look at is streamlit. But before I go into that, I want to quickly show you what this pipeline looks like in a diagram. So I have another repository, and also I've done a talk on this. So LangChain Azure AI Search RAG. I'll make sure to link it down in the description. I did this at All Things Open last year. So basically this is what the diagram looks like. Here we created project ideas for a given Azure certification, but what I'm doing today is pretty much similar. The user comes in, it asks about something that is in the PDF to the LLM. The LLM might be aware or might not be, depending on what it was trained on, right? Hence, we'll use this to provide, you can think of your own documents. And since you're running this locally, the information is not being sent somewhere. At least do your own research for confidential data. But since Ollama runs locally, I don't think the models send that information, but please do your own research before feeding in any confidential information. So DeepSeek might not know what PDF we are talking about. So what we have done is we have created a vector store right here on which, once the user asks the question, we do a similarity search. On that similarity search, some of the docs are returned, which we have here, and those are passed to the LLM. So the LLM has the relevant context, and then it gives us the answer. Pretty cool, right? So let's go back to our code editor and let's look at streamlit.py now. Okay, so this is our streamlit.py. And as you can see, I'm importing Streamlit as ST. If you don't know what Streamlit is, it basically allows you to create web application or web interface using Python. I've also imported main as main, so this will give us access to the functions that we created in main.py. And then as you can see, I'm using Streamlit to create a title called Chat with PDFs with DeepSeek. Now, the first thing I need in the interface is the ability for user to upload their file or their PDF, right? So here I'll be using st.fileuploader. You'll see once I start the application, but it basically lets us upload PDF. You can also set the file type, and I am not accepting multiple files, so I've set that to false. The next would be to have an if statement. So if uploaded file, which means if the user has uploaded file, I want to use the upload PDF function from main.py. This will save the uploaded file to the PDFs directory, as you can see, using this function. I also want to create the database, right? Or our vector store. So what I'm using is the create vector store function from our main.py, and I am passing in that uploaded file. So the uploaded file, as will be stored under the PDFs directory plus the upload file name. And then we also want to create an input on our interface. So on our website, we'll need to have a text input or a chat input. As you can see, I am using the Streamlit chat input here, which we are saving in the question variable. So now we can use this similar logic to build the further functionality of our web interface. Pretty similar to how we had the if statement. What I can do is have if question exists. What I can do is have if question exists. I am assigning the question that the user entered as the chat message for the user within Streamlit. So this will appear on the web interface after the user has inputted and hit enter, right? And after that, what I want to do is retrieve the relevant documents from the vector store that got created. So the retrieve docs function is being used here. I pass in the DB, which was created previously. Also the question from the user. So if the question is, again, for example, NVIDIA stock, that will be used against the DB, which is the vector store, to retrieve the relevant docs and store them in related documents. Now, in order to create the answer, I'm using the question_PDF function from main.py, passing in the question itself from the user and the related documents that we got here. And we are storing the answer in the answer variable. Then we use the streamlit chat message again. This time we give it the tag of assistant, and we use that answer we got previously in the interface. So it'll look like a chat application. Just so that I can show you the retrieval process, I have an st.text, which basically allows me to do any query. So here I can put, depending on what PDF we upload, like NVIDIA stock. So this will show up at the end of the page, just showing you how retrieval works. But for now, let's comment this out and let's save it. So I feel pretty good. And let's go to our terminal. First of all, we'll have to enable virtual environment. Again, all of this will be available on GitHub, so you don't have to worry about the instructions, So I'll activate my virtual environment since I already have one. There we go. I've also done pip install -r requirements.txt, which installed all the packages. The next thing to do would be run my Streamlit app. So streamlit run.streamlit.py. As you can see, it'll open up a browser window on localhost 8501. And now you can see, as I was saying, Streamlit allows you to build this cool interface. So chat with PDFs with DeepSeek was the title. We get an upload box here. So what I'll do is I'll upload this sample invoice that I have, and I can show you what that invoice looks like. There we go. So this is a sample invoice that I uploaded. And as you can see, our functions are running. There's like a athletes on the top that tells you there's some processing being done. So now what I can do is, let's say, what is the price of apple? So if you look at the invoice, you can see there are organic items. So apple, oranges, watermelon, mango. Apples are $5. Pretty simple doc, but I'm just using this as an example. So you can see the price of each apple is $5 per kg. But what is cool is this think tag. So there's a starting tag and a closing tag. It basically shows you the reasoning behind DeepSeek. So it says, okay, let me try to figure out how to answer this question. This user is asking about the price of apples. I remember they gave some address details, but I'm not sure if that's relevant here. They also provided an invoice number and list of items with their quantities and prices. Looking at the data, apple is priced at 5 per kg, sold in 1 kg. That is from the retrieved docs, and it was able to give us the $5 per kg, which is right. If we look at our terminal, you'll see, since I had that print statement, I go back to my code editor, go to main.py. In the retrieve docs, I had a print statement to return the similarity search docs that show up. You can see that that document was returned here, and you can see because the similarity search had apple in it, or the query or the user query had apple in it, which basically means the similarity search had apple in it. This is where it was able to retrieve that, because this document was returned as context. Cool. So what we can do is, let's try another PDF. So what I'm gonna do is delete this one, go back here, and let's browse files. This time I'm gonna use the AWS Certified AI Practitioner Exam Guide, and I can show you what it looks like. It's a 20-page exam guide, basically talking about the AI practitioner. Let's go back to Streamlit and say, what type of questions we're going to ask, what type of questions are going to be on the exam. Let's see what answer do we get. So here's the answer we got. Again, this is the think tag, right? So below that, below the closing one, is the answer. The exam consists of question types including multiple choice, multiple response, ordering, matching, and case study formats. So this is what it got us. Let's look at it. Pretty sure it's right. Oh, there we go. So question types: multiple choice, multiple response, ordering, matching, and case study. Awesome. It focuses on evaluating knowledge of definitions, tasks, strategies, governance, compliance, data management, and case studies in AI and ML contexts. That is pretty accurate. This is how you can use DeepSeek today for free using Ollama. Make sure you have enough compute power, but the model, if you look again, is available in different parameters. So 1.5 billion, 7 billion, 8 billion, 14 billion, 32 billion. Depending on what you're able to run, I would say pull that model accordingly, and kind of you can build anything with this logic. Let me know in the comments if you would like to see like a chat application, similar to ChatGPT or Claude that you see online, that you see on their portals. We can definitely create something with Streamlit, LangChain, and then Ollama with DeepSeek to run locally. That was the video. I hope you liked it, and I'll see you in the next one. Peace.